Hello and welcome back to another episode of Math with Sohn. Today we are going to be continuing momentum and really going into the idea and doing some practice problems involving why it's important for an airbag to exist and why and how it actually matters with physics. So, momentum is mass times velocity, and we want to take this scenario where we have an airbag and we want to change our momentum, because momentum is how hard it is for us to stop something, and which relates to force, and we want to relate it to essentially impulse. So the change in momentum is equal to force times time from our previous video. And if you take the change in momentum and you think about it as the momentum in the beginning and the end, and you find the difference between them, so the change in momentum, Pf minus P initial, would equal force times time. And then if you think of momentum as mass times velocity, you got your mass times your velocity final minus your mass times your velocity initial would equal force times time. Now all of this to bring me to this key point. If you solve for force here, you would be dividing by time. And the key here is we divided by time. Mass velocity final, that's a bad looking F, minus mass velocity initial divided by time. Because we're dividing by time, the longer the time, the bigger number you divide by, the smaller the amount of force that would actually occur. So the longer you can actually delay the change in velocity and therefore the change in momentum, the less force would be applied and the less boo-boos you would incur during a collision. Okay? So let's do an example with that. We got example D. A soccer player can apply a force of 30 newtons to a ball with a mass of 1.5 kilograms if the player remains in constant contact with the ball for 0.7 seconds. That means the collision is occurring. He is kicking the ball before it leaves his foot, essentially. That happened for almost a second, 0.7 seconds. All right? So we're going to use the Pf minus Pi version of the formula is equal to force times time. We want to know how fast is the ball moving as it leaves the player's foot. So we're going to convert this into mass Vf minus mass Vi is equal to force times time. You could solve for some of the variables we're looking for when it leaves the foot. So that would be mVf essentially. So if we move the mvi over, we'd have mvf is equal to F times T plus mvi. And then we could divide by mass if we wanted to, or we can plug in the mass at this point. The mass is 1.5. So we got 1.5 kilograms is equal to the force of 30 newtons times a time of 0.7 seconds plus 1.5, and then it said the initial velocity it was at rest, so that would be times 0 meters per second. And if we do the math here, you would have 30 newtons times 0.7 seconds, which is 30 times 0.7 divided by 1.5, 30 times 0.7, and then you would take the 30 times 0.7 and divide by 1.5, and you would end up with, I forgot my VF. You would end up with a V final velocity is equal to 1.4 meters per second. No. Nope, I lied. 14 meters per second. 14 meters per second. The answer key was wrong, and my calculator was saying one thing, the answer key was saying another. All right, another example. We got a few more before we are done with this video. We got the rebound speed of a 0.5 kilogram ball falling straight down that hits a floor moving at 5 meters per second if the average normal force exerted by the floor on the ball is 205 newtons for 0.02 seconds. So essentially what we have here is we got this ball falling, and it originally had a velocity of 5 meters per second. Looks like I wrote 51, 5 meters per second. And we want to know what would be the speed when it rebounds. So it hit the ground at 5 meters per second. What is the final speed as it's coming back up? Knowing that it has this normal force applied when it's hitting the ground of 205 newtons. Okay, so it's the same exact formula as we had before. We got force times time would equal your mass Vf minus mass Vi. You could even factor out an m if you wanted to. Vf minus Vi. Sometimes that would be a little easier. We got the time as 0.2 and so on and so forth. I'm going to plug in the variables now. Let's do that. 205 times 0.02 would equal the mass. The mass is 0.5. Vf, we don't know. Vi, we do know, which is 5 meters per second. And then we would we would divide by 0.5 and then add 5. And when we divide by 0.5, dividing by 0.5, and then adding 5 over, you find out your final velocity is equal to 3.2 meters per second. I'm trusting my answer key this time. I'm not busting out my calculator. All right. Next one. And last one. A force acts on a mass of 3 kilograms that is initially at rest. The force versus time graph is given. So when you're given a force versus time graph or any type of graph, you're either looking for A, the slope, or B, the area. And remember, it depends on the question. So it's asking what is the impulse imparted to the object in the 5-second interval. So this entire 5 seconds. Impulse is change in momentum. Change in momentum is force times time. If this was a rectangle, you could just do 6 times 5, but it's not a rectangle. We have a rectangle here, so the impulse for the first 2 seconds would be 6 times 2. So let's do this in 2 different intervals. We got 6 times 2, so the impulse for the first 2 seconds would be 12. But then we have this triangle afterwards, which would be 2 times, not 2, it'd be 1, 2, it's a 1, 2, 3. This part from here to here is 3, and this part up here is 6. So you have to do 1/2 base times height, which would be 1/2 3 times 6, which ends up being 9. If we put this rectangle, which had 12, and this triangle, which has 9, together, you end up with 21 as the impulse area. And the units for that would be Newton seconds. Find the final velocity of this thing. So here we could do the impulse is equal to mvf minus mvi, and it started at rest. So if it started at rest, that part would be like gone, and it's 3 kilograms. So the change in momentum would equal 3 times vf. Well, what was the change in momentum? That would be the impulse, and we just found out that was 21. And if that is 21, then we would have 21 is equal to 3 times Vf, and 7 would equal Vf, meters per second. And my answer key is wrong again, so I'm going to have to double check this one. But I'm pretty sure that my math is right and the answer key is wrong again. I'm going to trust it. As long as this triangle is, in fact, 1, 2, 3 by 6, then we're good to go. 3 times 6 is 18. Yep, I'm good. I'm done finagling with it. Until next time we're going to go into collisions even more and the conservation of momentum. So I look forward to seeing you then. Till then, have a good one. Bye, folks.